Okay, looking at rewriting radical expressions. We've kind of done this already a little bit. We're just going to expand on it some more. The question that I've asked you a lot pertaining to this is square rooting. Square rooting something is the same as raising it to the power of what? 1/2. Okay, which is what that right there is saying. Okay. Now, make sure you know what I mean whenever I say a rational expression or a radical expression. If you have a rational exponent, which it explains it right there, it's an exponent that can be expressed as m over n, where m and n are integers and n cannot equal 0. All that means is you have an exponent that's a fraction. Okay? Don't overcomplicate that. Rational exponent. It's an exponent that's a fraction. That's all that means. Okay. Radical expressions can be written using rational exponents. Make sure you know what I mean whenever I say a radical expression. This is a radical sign. So anything I write with one of those in it is a radical expression. That's all that means. So if you look up here, radical expressions, down here, all this is rational exponents. It's got a little diagram as to how to go back and forth from these two notations. And now if you've got an exponent underneath the radical or outside, those two are the same. And we'll write them those two different ways. But either way, you're going to end up writing it like that. Now most people, they struggle going from rational to radical. And this seemed to have helped some people, because all that has A, M, N, all that stuff, but you don't really know what it is. So this just kind of tells you what those things are. So your denominator of the fraction is always going to be in front of the radical. The numerator is always going to be the exponent. And then your base is what is still the base underneath the radical. So hopefully that will help you from being able to go from one to the other. Going to this table, make sure you know that this is just kind of telling you that raising something to the power of 3 is the same, or is the opposite as raising it to the power of 1/3. Okay, 2 is the opposite of 1/2. 10 is the opposite of 1 over 10. So if you have 2 cubed, what is 2 cubed going to equal? 8. So 8 to the power of 1/3 is what? 2. 3 cubed is what? So the cube root of 27 is what? 4 cubed is 64 to the power of 1/3. 5 cubed, the cube root of 125. Now if you noticed, whenever I was saying that column, I wasn't saying the same thing each time. I either said to the power of 1/3 or the cube root of the base. Whenever I see the power of 1/3, my mind, I'm able to figure it out easier if I read it as the cube root of whatever, as opposed to the power of 1/3. But they're the same thing. Okay, so using those property exponents, this is one way you can do this. I wouldn't necessarily do it this way, but we'll talk about this just given this situation. Those two things are the same though. Okay, 9 cubed to the power of 1/2 or 9 to the 1/2 cubed. Alright, but if you end up doing it this way, which is fine, you might want to know which way is a little bit easier to write it. Which, if I have 9 cubed, which means I have to do 9 times 9 times 9, and then do the square root of it, is that going to be easier than doing the square root of 9 and then cubing it? So which one, the first or second one, do you think would be easier? The second one, because what's the square root of 9? 3. What's 3 cubed? What is it? 27. Thank you. If most of you actually tried, you could probably do that in your head. Alright, it's not that hard to do 3 times 3 times 3. Okay. Going to this down here. So this is really getting into going, again, from one form to the other. We'll write the radical notation these two different ways, just so if you see it in either way, you know that it's the same. But if I write that with a rational exponent, x is going to be my base. But am I going to write that to the power of 3 over 4 or 4 over 3? Haley? 3 over 4. Okay. Because this is where your denominator is, and this is where your numerator is. Next one's pretty easy because I think I've asked it multiple times. Raising something to the power of 1/3 is the same as doing what to the base? Cube root. Now, normally you would not write the 1 there. I'm going to go ahead and do it just because we're kind of writing it those two different forms. So, looking at the next one. Miss Clark, what number would go in front of my radical? There's an x, a 2, and a 5. Logan? If I'm writing this into rational as a radical. There you go. So I've got that, and then I've got the 5th root of x squared. And then the last one, Keenan, taking the 5th root of something is the same as raising it to the power of 1/5. Alright, so I'm going to have you go through 1 through 7. I'll do 1 with you, but you'll do 2 through 7. And you're going to simplify it down as far as you can. If you can get a whole number, that's how I want you to write your answer. If not, you'll leave it in whatever form you go to. But if it's in radical, I want you to change it to rational. See what it equals? If it's in rational, I want you to change it to radical. Alright, and whenever you change forms, all I want you to do is put it in your calculator. Practice putting in the 4th root or whatever. Which we'll make sure everyone's good on that here in just a second. So on number 1, this is going to be 16 to the power of what? 5 over 4. Which if you put that in your calculator, you should get 32. Now, whenever you end up with something like this, the 5th root, or cube root, or 4th root, or whatever, how do I put that in the calculator? How do I do cube root in the calculator? Math 4. Okay, so if you hit Math 4 in your calculator, you can arrow over to where that 3 is and change it to whatever number you need it to be. So if you do 5th root, Math 4, but change the 3 to a 5. Alright, so go ahead and start going through 2 through, even though there's only 7 here, the next 3 on the next page, you can go ahead and start doing that as well. And I'll be a minute or so behind you on these. So for example, in number 5, that comes out to probably 1 point something, maybe, I don't know. Just leave it at 7 to the power of 1/3. So those 3 down there, if you put it in, it will give you a decimal, but just leave it as rational exponent. Okay, so there is 6 and 7. Any questions on any of these? These hopefully are pretty simple. Yes, ma'am. Going to these. Hopefully you already have these done. These as well should not have been too difficult. You're just going now to radical notation. You'd have the cube root of 4. The 7th root of 5 to the power 4. The 5th root of 7 cubed. Look at this statement right here in the middle. Listen. Alright, looking at this part right here in the middle, make sure that you're aware of this. It says, if the radicand is negative, that's just the number underneath the radical. Okay? We just don't call it that. I just say normally, hey, that's what's underneath the radical. And the index, which is out here, okay, so this index is 5, 7, 3. And the index is even, the result will be an imaginary number. Now, you're not going to see this a lot, at all. Okay, but we've talked about imaginary. You have a negative under the radical. So you would pull an I out, and then from there you would just go along the regular process. But if that index is odd, so if you have the cube root of negative 8, you can do that and get negative 2. And you are likely to see something like that. That is easily fair game. Okay, so don't just see the negative and think, oh, it's going to be imaginary. It's the negative in the index that tells you whether it's going to be an imaginary number or it's going to be a real number. Okay? Yes, ma'am. So, let's come down here. I'm going to work this first one because these are going to be a little bit different how you do these. You're going through here and simplifying it. So the first thing you're going to do is you are going to go from radical to rational, but then they're going to have another step in which you will need to simplify it. So, once again, for what feels like the 100th time, cube rooting is the same as raising it to what power? 1/3. So now I need to do power to a power. So am I going to multiply 8 times 1/3?
Yes.
No. I'm going to cube root. Remember, raising something to the power of 1/3 is the same as cube rooting it. Am I going to do 1/3 times 6? Power to a power.
Yes.
Yes. What is 1/3 times 6?
2. Because it's square root.
Yeah, when you have to, oh, that makes sense, but yeah.
Dude, so I was right.
No, Cameron, that's right. It's 1/4. The other one's 1/2.
Oh, yeah, I'm on number 13. I did 1/2.
Yeah. So it's basically just X plus 2. Okay, so now whenever you're trying to get.
So, we have our quiz next class?